So, this is my wonderfully titled Reeling You In on React Hooks talk. Please contain your laughter. I know how funny it is. I really do. Uh, but React Hooks is a somewhat new feature in React. And it's kind of like how you do things in React nowadays. So here's a short story of React. In 2020, I know laughter barley contained. Come on, dropping the ball. You got to get spell check. Just kidding. I'm terrible at spelling. I'm one to talk. Anyways, so 2012. I'm actually gonna minimize this because I realize you can't see part of the. Hang on. How do I move? I just let me. Whatever. Fine. You just have to deal with having some opacity over here. Anyways, so in 2012, a guy named Jordan Walk has a side project, turns into React, and then Facebook was like, "Hey, let's rewrite Instagram in this," which was a weird move, but worked out for them because in 2013 they open source React, and that's when it hit the big time. 2015 is when ES6 came out. I mention this as a point of importance because notice how there's a 2-year gap between ECMAScript 6, which is when JavaScript classes were introduced, and 2013, which is when React was introduced, right? So React, even though it has been kind of like well known as a class-based library up until hooks were released, it predates JavaScript classes. So we'll touch on that in just a second. And then in 2018, hooks are announced, right? Hooray! So I mention this because I think that understanding a bit of the history behind React is pretty important. Not necessarily to use hooks, but more so to understand why hooks are the way that they are, why they rely on index order and some other like ingrained details once you start getting further and further along. So the way that React used to work, and still does work if you're using classes and not hooks, is that you have a component, which is a class. That class has different methods inside. It's not what I meant to do. I meant to do this because someone is messaging me and I want to close that window before it annoys me. So you would have a class. That class would have methods. And then those methods would run whenever the component was mounted or unmounted, or if there were properties that were updated. So if you're familiar with what a component is, it's just like a little bit of UI code that has a bit of logic inside of it. So when it rendered on screen, you could make it do a thing like go grab data from your server, etc. When it updated, you could say like do a mathematical calculation on the properties and then update them in a certain way. And then when it unmounted from the screen, when it left the screen, you could say do some cleanup, whatnot. So in 2016, 2 years before hooks was announced, people were asking Dan Abramov, who's one of the core members of React, what are you going to do with functions? Like, are function-only components going to exist? Because classes kind of go against the general design pattern of React. A lot of the React ecosystem is built around functional programming, and having classes in there kind of muddies the waters a bit. And originally the response was, hey, we're not going to do that. We have no plans to right now. 2018 rolls around and hooks are introduced to add a lot of the lifecycle method and other logic into React. That said, you don't have to understand the lifecycle method to learn React or React hooks. So what are hooks? A hook is a function that starts with the word use and is camel cased. So use state, use reduce, use whatever. That's it. That's all a hook is, really. But that's not a super helpful answer. That's the truth. Technically, that's all a hook is. There's some additional work to make some of the hooks work in a certain way. But ultimately, it's just a pattern. It's a pattern that has a name, and just like object-oriented programming is a pattern that has a name, hooks are a pattern in React that have names, and it's just functions, effectively. So it allows you to use various class-only features. For example, you can say, when I mount something, do an action, or when a property updates, do a thing. I'm also going to move myself off screen for just a second. Okay, you should still be able to hear me. That works. And I'm just going to do this for the slides that have details right where my head would usually be. So here we have class compatible. So that means that if you've written any React components with classes before, which is, if you have a large scale React database, not database, but application for the past few years, it's very compatible with your existing code. And then finally, it's not the only way to write components in React. So there's no plans to remove classes. They're going to keep classes in React for as long as far as we know anyways. And we'll touch on why you might want to still write a component using classes instead of hooks later on. So let's get into the first one. This is UseState. So if you look at the code sample, here's a component called fishing bucket. Here we're defining an array destructure. So by default, UseState returns an array of 2 items. The first item is the actual value in that state, and the second item is a function that says to update the state. Here we're calling the set fish type to update the state to trout and salmon when you click on these 2 buttons. And then finally, when we display the name, it'll just render what's actively there. So let's open that up, take a look at what it's doing. So again, here's trout, here's salmon. If we click on these 2, it'll update what's displayed in the paragraph tag here. So we could also change this to be Superman or Spooderman. And now if we click back and forth, it'll be Spooderman or Superman. That's still too small. There we go. That's much better. Really, this is just a way of having statefulness and having that statefulness be functional inside of, another functional component, right? So that's nice. But here's some minor problems, is that if you're already familiar with the UseState or setState functions from classes, you'll know that those are partial. So if I have an object and I only want to replace one of the properties, not the whole object, that's not supported. I now have to replace the whole object every time. But that's the gist of it. That's UseState, right? So we now have the ability to store state in our functional components. Sweet. Love it. By the way, if there's any questions that you have, please feel free to stop me. Go, hey, what's going on? I don't understand that code sample. Like if you're questioning what this array destructuring thing is, I can stop and explain that, no problem. Keep in mind this is live, so I don't mind putting a pause on things. All right, so that's statefulness. What about effects, side effects? So side effects are a bit weird if you're not used to the terminology, if you haven't heard of it before. But the idea is that you can run code that isn't directly ran. So like your code is implicitly ran by other things happening rather than explicitly ran. And here's a great example of that. So I have 2 types of state. I'm actually going to open up this. So here I have 2 types of state. I have the fish type and I have the bait type. Here we're using a UseFX hook, and we're saying anytime that there's this array, here let me go back to removing myself, anytime that this array updates, so this component fish type updates, we want to run this bit of code. So we're not calling a function that says run this, run this, run this. We're simply saying every time that this array updates, implicitly run this code, right? So here, when we update the fish type to trout, it will automatically run this. It'll run this switch case. It'll find, hey, fish type is now trout. We should update the bait type, right? So now if I click back and forth, you can see that when salmon is selected, it updates row. And when trout is selected, it updates the smelly stuff. Apologies for the lack of technical terminology in the fishing. I don't actually know what the smelly stuff in fishing is actually called because I am not a good fisher. So, UseFX, this is a pretty bad use case for effects, to be honest. It's probably the most straightforward example of a use effect, but it's not great in production code. A better example would be something along the lines of making a call to a server. You only want to do that once, so your dependency array, which is the second property here, would just be an empty array. So it would only run the service call once to the server, and that would return the data. You could use a set state and then update the state, and then you could have your server data in there. That's a good use case of UseFX. So the second argument says when to rerun. So in this case, we have fish type. We could add more to this so that anytime any of the items in the array updates, it reruns this implicit code, this side effect. And also something that's very useful is that you can return a function here, so return new this array, and that will do cleanup. So anytime that this reruns, it will run this first and then run the new instance here. So here's a good example of that. So if you're familiar with timers in JavaScript, so set timeout, use timeout, stuff like that, you can set a timeout for 5 seconds so that this doesn't update for 5 seconds. So notice how that took a while and now it's updated. Same thing going back and forth. So it's a way of like deferring the timer. But here's the thing. If I switch back and forth and back and forth and back and forth and back and forth, what you might expect to see is you might expect this to now update 40 different times back and forth and back and forth and back and forth. But notice that it doesn't actually do that. It updates once and it stays updated. And the reason for that is because every time that this code reruns, anytime that fish type, the dependency array, is updated, it will run this cleanup to clear that timeout. So we have a timeout set up here, right, for 5 seconds. And then if this decides that it needs to rerun again before that 5 seconds is up, we want to go in here and we want to clean that up to make sure that that timer is stopped, doesn't try to rerun, so that it's only updating once rather than multiple times. So having UseEffect and the ability to rerun multiple times based on what's in your dependency array and being able to clean up every instance that it's ran is super, super useful. Like honestly, these two hooks that I've just taught you about probably covers about 80% of the code base in my side projects. These two hooks are super powerful on their own. So that's UseEffect. So now that I've covered the 80%, why hooks, right? Like what, like we already had classes. They did all this stuff anyways. Why do we need hooks? Well, it's concise code for one. So if we look at a comparison between, I'll show you how we used to do it in classes. So here we're defining a class, right? And we have the state, which is bait type. And we have a set bait type function. We have the switch case that we had before as its own function. We have a component did update. So when it does update, it runs the switch. When it did update, if the properties have changed, run an update and then render all the data. But that's not all. We also have to now have a parent class. That parent class has its own statefulness, so its own object with its own set state, with its own method, with like, so we're already at 61 lines of code versus what we had before, which was the functional component. We have one use effect, we have two sets of state in the same place, and that's it. 26 lines of code, right? So like, that's a huge advantage. Like, not only is it less code, which isn't always inherently better, you know, there's a kind of fine line to walk between dry and wet code, which is effectively like, don't repeat yourself, and also like being okay with repeating yourself when abstractions don't make sense. So more lines of code doesn't necessarily mean better, but like, for this example, this is a lot harder to follow, right? Like this, you know, you have one component and then you have another component and then you have a bunch of different lifecycle methods, and like it's just kind of hard to follow. Meanwhile, the hooks, way nicer to follow. Keep in mind that this isn't like a universal truth. It's not always more concise code, but it oftentimes is for very common use cases. So that's a good reason. Code optimization. So if you have something like a class method, you can't tree shake that, right? Like you can't tree shake a method. You can't tree shake, which is, sorry, I need to back up a second. Tree shaking is the ability to remove code that you're not using from a library that you are using. So for example, if React has 4 hooks and you only use one hook, it has the ability to remove all 3 of the other hooks from your package, which makes it much lighter, easier to ship to a client, and much faster. So classes just muddy the waters with code optimization. It can make tree shaking a bit harder. But here's the coolest part about hooks. You can share code. And that might not sound like a lot, but that's huge. So let's take a look at that. We can write our own custom hooks. So a hook is simply a function, as I mentioned at the beginning. But that means that we can use other hooks in our hook. So we have a function that just starts with use blank. So in this case, use competition fishing pole. We have the fisher's ID, so like their name or whatever, and then we have how many times they've cast their reel, right? And then we have a global state of winner ID, and if there's no current winner, then do a random check if they are. If they haven't won, then no one's winning, and then if they did win, let them know they won, right? Like that's pretty simple. But what it means is that we can now implement this in a few different places. So we can have two different people that cast the line, and we can say something along the lines of have two people have two different instances of this hook, and then set disabled if one of them is won. If not, set the cast to +1 and then see if they won, right? So like this is 40 lines of code, and I can guarantee you that this would have been not only more lines of code, but we wouldn't have been able to do something like this where we share the same function multiple times that has like a use effect and use state. Like it would have had to been a method call, and then you would have had to do this and this and this. So being able to share those states and the updates and all the logic that comes with them inside of a custom hook is extremely powerful. So going back to third-party libraries, if anyone had used Redux before hooks, what you might have seen is you might have seen something like with state and then your name of the component, so like comp base, and then you'd have to do like export const comp equals with state, and sometimes it would get really complicated. You'd be like with style, with state, with blah 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 blah, and it would just be like these are called higher ordered components, and these would just be like this huge conglomeracy of function calls that you'd have to put under your comp. And then if you were using TypeScript, it didn't work super well. Like sharing state and sharing lifecycle methods before hooks was such a frustrating process. Like nobody seemed to like how it was done. And nowadays, third-party libraries can just write hooks. They know that you're going to have UseState. They know that you're going to have UseFX because those come baked into React. And they can just ship their own hooks that you can utilize, and makes their APIs so much more nice and compatible with functional components, not just class-based components. So very cool. But wait, there's more. There's not just those two hooks. There's tons of others. Let's go over a few of them. So use context, right? If you've ever used React and have come across the context pattern, it's super, super cool. So one of the big frustrations with something like Vue or Angular or one of these libraries is that you have a tree, right? So I'm going to be a bit of a cross-referencer here. HTML. Right? So like if you know how HTML works, it's very similar to this. This is an article that I wrote about how your browser understands the DOM, which is like the hierarchy of components that HTML creates in order to render things on the UI. So here you can see that we have a parent of the tree, which is main, right? And then that parent has two children, and then those have children, and so on and so forth. It's the same concept with React, right? React has parent components, and then those have children components. Well, the problem is, let's say I have a piece of data at the very top component, and I want to pass it all the way to the bottom component here. What I usually have to do is something called prop drilling. Prop drilling would let me say something along the lines of, hey, IDB, here's some data. Hey, IDD, here's some data. Hey, item 2, here's some data. And like, the problem is that you have to copy and paste that everywhere. So now you have the same copy and pasted code about 30 times throughout your components just to get data from point A to point B. Well, what if we had a way to teleport code, teleport data directly from A to item 2? Just directly to it. We don't have to pass it to, we don't have to play this game of telephone where something could go wrong. We can just teleport the data. That's effectively what context is. So we have a provider, and then we have a consumer. So we have something like fish context, which is create context trout. And then we have a provider. Actually, let me load up the demo really quickly. It'll make it easier to highlight some code. So yeah, like I was saying, we have our provider. And in our provider, we provide the value, so fish. And then we have the fish bucket, which we're passing it to. And fish bucket is using fish type, right? So that's use context. It's grabbing data from that like teleportation area of fish context. And then it's able to display that data on the screen, right? Just like it was doing before. But now we don't have to pass it as a property. We can just inherently grab that data from the context. So that's super cool. Especially because if you've ever used something like Redux, this is effectively what Redux is. It's a way to teleport global states from one place to another without prop drilling. The nice part is that if you're using a lightweight application, you might not need Redux. You might just be able to get by with some context. Furthermore, you can extend context with something called UseReducer. So again, if you've ever used something like Redux, if you've ever used a flux pattern, maybe NGRX if you're on Angular, or Vuex if you're on Vue, you'll recognize this pattern pretty quickly. So we have this idea of a state, like an original state. In this case, the original state is fishing for trout, caught fish 0. So that's the original state. And then we have a whitelisted set of actions, like an allow list of actions. We have the catch action, which adds 1 to the existing caught fish. We have release, which removes 1 from the existing caught fish state. We have set fish, which defines like what type of fish we're fishing for. And then we have default, which basically says if we're not doing anything, just make the state stable. So here we can cast a line and we can check whether we caught something or not. And we can provide that as the value from the provider. And we can dispatch the action of set fish or catch. And all of that is provided without having to do any prop drilling, without having to maintain a complicated state. So like, notice that there's no functions here for when I caught a fish, because it's just defined in one line of code, right? So like a reducer is super powerful. You can have a huge list of items that you want to be able to have action on the state. So like updating how many items are in this cart, updating who is in a chat, something along those lines. All of that can be an action in a reducer, and it will reduce the amount of code you needed for a complex global state from a lot to a very, very, very small API, which is super nice. So combined with Redux, or combined with context and reducer, you can eliminate Redux from even medium-sized applications. In fact, there's a few larger scale applications that I know that have just used UseReducer in favor of Redux. So this, if you've seen my talk before, this is a new one, UseRef. A new one to the talk anyways. It's not exactly a new hook. It's been around since the introductory. Of course, it's deciding that it wants to show both of them. That's cool. So UseRef is the ability to store mutable data in a component instance. What? Like what does that mean? So a mutable data set is the idea that you have an item in memory, and instead of copying and pasting that data every time you need more or need to update it to a new variable, a new place in memory, instead you keep that element and that code inside of the same memory address and you modify the data inside. So this would be something along the lines of like using a pointer in C to modify data inside of a variable rather than creating a new variable and assigning that data to there, right? So ref is the ability to create a mutable data set, which you can then mutate in some way. So in this case, we have, I want to do this example first. Do I want to do this example first? Yes, I want to do this example first. So here, what we're saying is we have a timer, right? And when nothing happens, so at the very start of this component, since there's an empty array to the use effect, I want to set an interval that sets the time to itself -1. That's what this arrow means. It just means take the current value and return 1. If it's 0, return 0. And I want to update that every second. So we have 100 seconds. Every second we want to remove a second. And then we want to update the ref to be the current ID. Well, the problem is if we leave this page and then we come back to this page, our timer will keep going. So the second time we load the page, it won't be removing 1 second. It will be removing 2 seconds per second. So your timer will be fast. And if you re-render the page, same problem. So it's like this continual issue of like your timer is going faster and faster and faster and faster and faster because you're not cleaning up the previous timer when you're leaving. So that's why we're using the return arrow function to do the cleanup of clearing the interval. And then here we just have a paragraph tag that shows how many seconds you have left. And we have the reset timer button. So it's at 97, 96. We can reset it back to 100, so on and so forth. And that's cool. So I guess the question would be, why ref? So you could do the same thing using UseState. You could do const timer, and then we could have set timer, and then we could use UseState. The problem there is that it would cause a re-render every time you update the time, which, well, the time updating is causing a re-render because it's in UseState, but we wouldn't want to cause a re-render whenever the timer is updated, the timer reference is updated. So it's a bit contextual. It requires a bit of understanding of like some of the lifecycle methods and what causes triggering of re-rendering and when you need to be aware of re-rendering. So that's one use case for useref, which is a bit abstract, so it's totally fine if you're not clear of it. The other use case of useref is probably more commonly known, and it's used as an element reference or a reference to a component. So here, most components have, or elements have a ref input. That ref input can be passed the item from useref. And then here, what we're saying is get a reference to the div. The div by default is not styled blue. It's just height and width of 100. So if I comment this line out, that blue box goes away because it's there, but it's not styled blue, right? So we can even say background red. There, it'll show up as red. But then what we want to say is when we get the reference, UseFX to update .current, which is the reference, .style. So we're modifying, if you look under the console log, we're modifying the HTML div element, which is the actual reference to the HTML element here, .style, .background equals blue. So even though we've set the background to red here, we're able to override the background using blue here. That's not super helpful on its own, but the nice part is that it makes it much more convenient when you start getting into things like integrating jQuery with React or integrating a library that's just vanilla JavaScript with React. So if you need to integrate something that deals directly with the DOM, but you want to have controls in React, having refs like this is super, super, super powerful. So now we're getting into some weird optimization territory. A lot of this stuff is going to be kind of vague, and I just have to say, read this article, this bit.ly that I'm linking. If you want to learn more about optimizing your React code, read that article 100% and pay particular attention to some of these examples because I'll try my best to explain it. And if I just don't get it across, that's totally fine. These are the more complex usage. So here we have UseMemo, which is short for memoization. The idea behind it is that if you have really complicated logic, let's say that I'm doing a multi-point calculation for 3D rendering or even 2D rendering, drawing, something. The idea is if I have a really complex calculation, I don't want to run that calculation on every re-render. So maybe I pass in a string of text to my component, and I want the string of text to render a new version every single render because that makes sense. But what we don't want is we don't want to have that complicated 3D triangulation or whatever. We don't want that to recalculate because that was a very expensive operation. Maybe it took 5 seconds, which would be a huge calculation, but maybe it did. And we only want to re-render that when the relevant data is updated. That's where UseMemo comes into play. So here, of course, I have to have the thing that I removed. Here I'm using a UseMemo just to do a switch case, which is not an expensive computation. This is actually malpractice of UseMemo. The problem is when I start showing real use cases is when it starts kind of slipping away and making it even less clear what's going on. But here, what we're saying is only update this memoized data whenever this array is updated, which is very similar API to how UseFX works, right? And then we're returning the URL for the image that's displayed, right? So again, super like simple use case here, but if you were doing a really expensive computation and display fish re-rendered, it would save you tons of time if you used a UseMemo on that expensive computation, because then it doesn't have to rerun that computation every time the UI updates. So that's UseMemo. It's used, whatever is returned from this arrow function is what's actually set to the fish image, or whatever you type in here, SDF. That's what's actually set there. So that's how UseMemo works. Finally, since it's not uncommon to use a UseMemo to return a function, the React core team figured, hey, why not just move forward and just give people use callback? Of course, I've copied and pasted the wrong code. Oh, no, I haven't. So here's an example of where you might use UseMemo or use callback. So here we have a UseMemo, and you'll notice that we have an arrow function returning an arrow function. That's because we want message callback to be a function itself. So to do that, we have to return another arrow function. But that looks real confusing, doesn't it? Like that just doesn't make a lot of sense. It's like, what's happening here? Why is that a function of a function? That's confusing. So let's say that you needed to do, again, real complicated triangulation, and you returned a function to make that triangulation possible. Well, then you can use callback, which is, instead of doing double arrow functions, you can do a single arrow function and then pass it in as if it's a normal function. It uses UseMemo under the hood, so this code and this code, the only difference being the use callback versus UseMemo, they do exactly the same thing. One of them is just syntactical sugar. So, excuse me, that bit.ly link I sent you, which outlines like when to use UseMemo, when to use callback. Those are great examples of kind of being careful with both of these hooks. Again, if you haven't quite understood the memoization and callback, it's really difficult to explain without getting a better feel of how to optimize code properly. So just make sure you kind of spend time and experiment with it, read up on it. Kind of one of those things where absorption helps a lot. So that's been why hooks, right? We've gone over some of the hooks. We've explained how they work. Again, please feel free to stop me and ask questions. If there's anything you want me to review, I can totally do that. So that's been why hooks. Let's look at why not hooks, right? There are still classes. Why not hooks? So here's the 4 examples that I could think of. 1, cost-intensive refactors. If you've spent $500,000 as a company and you have hundreds and thousands of lines of code in classes, you're not going to want to use hooks. It's not a fast process. It's not cheap. It's very arduous. It's very expensive. So that's one reason why, refactors cost money. They just do. They cost money. They cost time. They're annoying. So that might be a reason. Retraining cost. If you're super familiar with the minutia detail about classes, learning hooks again might be kind of frustrating. So like if your team just isn't caught up on hooks yet, might not be the time. You might want to wait for them to be more caught up. There's also no hook replacement for component did catch or get derived state from error. So if you're using an error boundary, you have to use classes for that. You can use hooks in other components and interop between them because again they're not mutual, they're not exclusive. You can use them mutually. And finally, and this one is like the most, like there should have been some asterisks here, contextual rationale, right? Like there is only one instance where this has happened, but it was a really important instance where I was reading through some code and I thought, wow, I don't want to refactor this. Not only was it like, wow, I don't want to refactor this because it's going to take me a long time, but I actually did refactor it and I went, geez, this is hard to read, right? Like the specific use case that I was using, and it was like a calendar component and had all these like complex render logic. And it was like, I don't prefer the hook version. It's so much harder to read. It's harder to parse. It's slower. Like I just don't like it. So while hooks are kind of like the new fashion and like what people tend to prefer nowadays, they're not the only way to do things. So just something to keep in mind. And that's been the talk. You can find me at these handles. You can find me kind of wherever. Do I have socials? I do. Yeah, there we go. But yeah, so that's been